Hello, algebra classes. Let's take a look at our lesson that deals with measures of dispersion. So in our previous lesson, we looked at central tendency measures. We were looking at how we can find the middle or the center of a data set, what number or what value would best represent the middle of all the data. Now we're going to take a look at how is the data dispersed, how is it spread out. And we're going to find a couple different ways to be able to describe these measures of dispersion, how much the data spreads out and what type of spread there is. So for our guided practice today, we're going to look at finding the range and the mean absolute deviation of the data. We'll start with the easier one, and that's the range. So here we have some weights of selected pumpkins. There's 5 of them. And we're going to notice that a lot of them are pretty close, 22, 21, 24, and 18, but one of them is a little tiny. So it's going to have a profound effect on our measures of dispersion here, as well as the mean. So all these weights will be in pounds throughout this entire guided practice problem. To find the range, all we're looking at is how far apart is the biggest and smallest number in this data set. So we pick off the largest value, 24 in this case, and we subtract off the smallest value, which is 5 in this case. 24 minus 5 is 19. So the range of this data here is 19, and it's representing pounds. So the difference between the largest and the smallest value in your data set will give you the range. And it's one way to understand the spread of the data. But those can be some very extreme values, the largest and the smallest, so we might want to have some other ways to say, well, what is the more typical spread of the data? And that might be a little bit narrower range than this. And remember, 5 is a very, very small data value compared to all the rest of these. So there might be a more typical spread. We might be able to understand this dispersion of the data if we take a look at a different way to calculate the spread of the data. And that's mean absolute deviation, which is abbreviated MAD, M-A-D. So the mean, and that comes from the word average, absolute deviation, and deviation means kind of like difference, how far away is something from the typical or the norm. So the mean absolute deviation is the average of how far away all the data is from the mean or the average of the data set. So let's see how this works. We're still using our same data here, these 5 data points. To find the mean absolute deviation, first find the mean of the data set. So what we're going to do is we're simply going to average these numbers. So we learned how to do that in our last lesson. So here we are, adding up all of the values in our data set. And then we're going to divide by 5 because that's how many values there are in our data set. And that's going to tell us the average weight of the pumpkins in this data set is 18. So it looks a little low because it's lower than these 22, 21, and 24 pound pumpkins. But remember, this 5 is going to pull down on that average a lot because it's significantly less than all the other numbers. So our mean or average of this data set, and we would say that's a number that represents kind of the middle of this data set, is 18. Now, continuing on with finding the mean absolute deviation. Next, find out how far away all the data points are from the mean of 18. And you're going to take the absolute value of the difference of each data point and the mean, because it doesn't matter if the data point is above or below the mean. So let's see, what does that mean? Well, what we're going to do is we're going to write down all of the data values. Here they are. And we're going to subtract off 18 from all of those data values because we want to know how far all of these values are away from the average or the mean of this data set. So we're going to subtract off 18. And then we're going to take the absolute value because we might end up with a negative value, and we don't really care if the data value is above or below the mean. And so when we take the absolute value, that's going to remove any negative numbers that we would be getting. So we're finding out how far each one of these values, 22 all the way down to our last value of 18, how far are they away from the average or the mean of the data set, which is 18. So 22 minus 18 is 4, the absolute value is 4. 21 minus 18 is 3, the absolute value of 3 is 3. 24 minus 18 is 6, the absolute value of 6 is 6. 5 minus 18 is negative 13, but the absolute value of negative 13 is positive 13. And 18 minus 18 is 0. So it turns out that that pumpkin weight is exactly what the average turns out to be for this data set. Okay, so we're going to add all these values up, and we're going to get a total of 26. And since we are averaging 5 values, we're going to divide by 5. And so here we have the mean absolute deviation, 5 1/5 or 5.2, depending on how you want to report that. Decimal or mixed number version is fine. So we are averaging the distances, all the data points are away from the mean of the data set. This 5-pound pumpkin is way away from the average of the data set. This 22-pound pumpkin up here is 4 pounds away from the average. So some of the data values are way away from the mean, some are pretty close. And this one happened to be right on, this 18-pound pumpkin. So the average of the distance that all of the pumpkin weights are away from that average of 18 turns out to be 5 1/5, or 5.2. This tells us that the mean absolute deviation of the weights of all the pumpkins is 5.2 pounds. That is, the typical weight of a pumpkin in this group of pumpkins falls in this range, 18 plus or minus 5.2. So adding 18 plus 5.2 gives us our 23.2 pounds here, and 18 minus 5.2 gives us our 12.8 pounds. So typically most of the weights are going to fall somewhere in this range between 12.8 and 23.2. It's a little narrower range than the original range we got just by subtracting the biggest minus the smallest number. So this gives us a little more specific, typical, well, what is the, where does most of the data fall, how far away from the actual mean? And in this case, somewhere between 12.8 and 23.2 pounds. So our mean absolute deviation is 5.2 pounds, and we're done with this guided practice problem, and it's time to move into your homework portion of this lesson. We'll see you next time.